Hello, my name is Dr. Hammad Haider and you are watching sqadia.com. Today, my lecture would include first week of development and it would include fertilization. I will briefly be touching upon mitosis and meiosis as well, zygote formation, how two pronucleus, which is male and a female pronucleus, unite to form a zygote. Then cleavage of zygote into 2 and 4 cell stages to form a morula. Then implantation of this egg, as well as we will be discussing a very important clinical identity, ectopic pregnancy. So, what are the phases of development? Phases of development are actually mainly divided into three stages. There is a period of zygote, which is from conception through implantation, that is occurring and within the first 10 days from the fertilization. Oocyte is released into the tubes at around 14th day. This is termed as ovulation. Once ovulation has occurred, by this time the sperms come and fertilize the egg in and around fundamental of the tube, and by the time the egg reaches the anterior posterior wall of the uterus and implants itself at around 7 to 10 days, this is termed as period of zygote. From this terms onward, from during after the first 7 to 10 days, initial 10 days, then starts the period of embryo, which is actually the stage of embryogenesis, in which all the organs are formed, the heart, lung, the kidneys, and every other organ, the bones and things are formed, and gradually they align themselves in such a way that a mature fetus is formed after 8th week of pregnancy. Once there is a seed embryo has crossed this 8th week of development, now it is termed as fetus, and this period from 8th week onward till birth is termed as fetal period or period of fetus. As I told you, I will be discussing briefly mitosis and meiosis, and this is very important to understand what actually happens to these nuclei or oocytes and spermatocytes before they fuse to form a mature zygote. Now, this is a diagram which is showing mitosis. If you have to remember the mnemonic, it's a very simple mnemonic: Prime Minister at T, PMAT. So there are four phases of mitosis. One is the prophase, then second phase is the metaphase, third phase is the anaphase, and fourth phase is telophase. So if you see, this is the time, this is the interphase, is this stage in which cell is at rest, it's not dividing. So what happens in a mitosis is that cells duplicates its DNA material and divides into two cells. So if there is n number of nuclei present, n number of DNA is present, it becomes 2n at a time, and then the cells divide to form n again. So how does it all starts? Initially, there are centromeres with centrioles. As we all know, these are present in the cytoplasm of a cell. They start to align themselves along the axis of the cell. As you can appreciate now, from here onward, they've started to migrate, one towards this area and another towards this area. As you can appreciate here, but this time the condensation of the DNA starts as well. The DNA becomes more condensed, intensely coiled. As you can appreciate in the nuclear membrane, there are holes and pores starts to form. As a result, the nuclear membrane starts to disintegrate. At this stage, this is termed as prophase, when the early mitotic spindles formation is taking place. That the centrioles are migrating, but they have not completely migrated to form two poles. By the time before and prophase ends and metaphase starts, there is a stage called as prometaphase. At this point, the centromeres actually align themselves and two poles have already been formed. We can appreciate that nuclear membrane has been already completely disintegrated. These DNA, which have divided themselves into from n to become 2n, are actually condensing and aligning gradually in the on an imaginary plane. From here onward starts the metaphase. By metaphase, as you can appreciate that these DNA are these chromatids have actually aligned themselves on a central axis, and then they will divide half by half. One will go towards this cell, another will go towards this cell, and this marks the anaphase. Now, this is important. Why I'm mentioning this is because these two cycles actually take place in oocyte as well. There is first meiotic cycle in the oocyte, and then there is second meiotic cycle. First meiotic cycle is actually like a metaphase, mitosis, that there is a duplication of DNA material. The oocytes duplicates all material, divides into two cells, but instead of the DNA in this, you can appreciate that actually DNA material has been divided into half and going to one cell and half going to other cell. Instead, what actually happens is that all the DNA material goes to the secondary oocyte and first polar body is formed in first meiotic division of the oocytes. Now then, now this is showing meiosis of the primary oocyte. Now, as you can appreciate, this is the primary oocyte. Now, this is the metaphase is occurring in this when centrioles have aligned themselves, two poles have been formed, and chromatids are aligning themselves on a central axis. From here onward, if this is formation of secondary oocyte and a first polar body further divides to form two polar bodies, and secondary oocytes completes the second meiotic division in which a mature ovum is formed and another polar body is released. So instead of this primary oocyte going through two cycle of meiosis and producing four cells, it still produces one mature ovum but three polar bodies. So this is important to understand that although one cell is not duplicated to form four cells in two cycles, still one mature ovum is there, but actually the three polar bodies have been formed which will be made redundant. So in this, but what is actually happening is, this is important, that if you just forget the polar bodies, here that it was n number of this, it became 2n by this time, then again it went n to this and n to this, and from this onward, from this is secondary oocyte is a diploid cell. It divides to form a mature ovum which is a haploid number which contains half number of chromatids, which is half n. So from 1n it has actually become half n. So mature ovum containing half amount of the DNA material, and from where the other half will come, that will come from the spermatozoa. Once the spermatozoa's pronucleus fuses with the mature ovum, this forms a 1n plus 1n to form a 2n zygote, which is a normal cell. So this is exactly another diagram which is showing what actually happens to the oocyte in evolution. Secondary oocytes get arrested in the meiosis II, as I've already told you that initially there's a prophase, then there's a metaphase. First meiotic division is like mitosis, that the cell goes through one cycle and produces one polar protein. In the second meiotic cycle, during the metaphase, when the centrioles have aligned themselves on the two poles and two poles of axis have been formed, chromatids starts to align themselves in the middle on an imaginary axis. At this time, the meiosis is arrested. That is, this instead of progressing from metaphase to anaphase, it does not progresses. And in this diagram you can appreciate, this is the metaphase time when these are the centromeres, these are the axes which we formed, and chromatid are aligning themselves in the central and imaginary axis. And as you can already appreciate, because first meiotic cycle has already occurred, so there is already presence of first polar body. Now at this point, this will be the rest of the meiosis, second meiotic cycle. If fertilization has to occur, then only this cell will quickly complete the anaphase and telophase to form two more polar bodies and a mature ovum. So at the end of the time, still a mature ovum will contain haploid number of cells with three polar bodies, which will be later on discarded. So, scandiosite arrested in metaphase II, completion of meiosis only if fertilization occurs, and if fertilization does not occur, it will degenerate itself accordingly. Follicular cells of coronary radiata protect ovum as it breaks through the ovary wall. We have discussed this in the previous lecture, that how evolution occurs. There are certain hormonal changes occurring, and then initially this egg or oocyte appears as a bud or tubercle on the surface of the ovary. Gradually, there's a bursting of the cells, and these cells around them are released, which is present in the Graafian follicle, and there are only thin layer of cells which is surrounding this oocyte, which is termed as corona radiata. Now these corona radiata protect this single cell from being exposed to different kind of environments. From there, this corona radiata and oocyte goes into infundibulum of where there are fimbria present, and actually they are taken into the uterine tube or fallopian tubes. So once the egg is in the fallopian tubes, it starts its journey from the fallopian tubes into the uterus. It has to reach the anterior or posterior wall of the uterus within 7 to 10 days. Normally, the viability is at 12 to 14 hours for a oocyte, and for sperm, it contains 12 to 48 hours. So this is important that coitus has to take place exactly the same time, because once ovulation has occurred, the egg will not survive more than for 24 hours. If fertilization does not occur within 24 hours, it will eventually die and be discarded. So coming to the acrosome reaction, or what actually happens is that sperms and egg fuse during in the tube. Once the egg is going on from the infundibulum or from the tube towards the uterus, the sperms come in and fuse. But usually, on average, a single ejaculate contains about 100 million of sperms, and all this 100 million cannot fuse. So what actually happens is there's a reaction called as acrosomal reaction, acrosome reaction, which makes it sure that only one sperm fuses with egg, and as a result, one pronucleus of the sperm fuses with one pronucleus of egg, and a single zygote is formed. Otherwise, if there be more than multiple sperms fuse, this would result in either multiple pregnancies, or this would result in an abnormal cell. Usually it does happen at times that it's more than one sperm fuses, which may result in monozygotic twins. If then there are certain terms called as dizygotic twins and monozygotic twins. It depends what kind of situation it occurs. If more than one sperm fuses, they usually results in a monozygotic twin. It usually isn't dizygotic twins, but if this one sperm and one egg fuse to form a single cell but divides in such a way to form two embryos, this may become monozygotic twins. So coming to the phases of fertilization now, what actually happens is the passage of sperm through the corona radiata is important. When sperm has to penetrate this corona radiata, if you go back to the previous lectures, I have already discussed that there is a Graafian follicle, the layer around it, then there is a small layer which is called as zona pellucida, corona radiata cells, and then there is zona pellucida layer. So corona radiata is actually the 2 to 3 layers of cells are actually surrounding the egg. Then there is a zona pellucida layer, which is a thick protein coated layer which is surrounding the egg actually. So it has to first penetrate corona radiata, then it has to penetrate zona pellucida, and from then onward it can only penetrate the plasma membrane of the oocyte to fuse, so that it can release its pronucleus into the cytoplasm of the egg. So what happens? Passage of sperm through corona radiata, the penetration of zona pellucida, and results in a zona reaction. I will be discussing acrosome and zona reaction in upcoming slides. Then there is the fusion of cell membranes and oocyte. Then at this time, once the pronucleus of the sperm fuses with the pronucleus of the egg, now after the fusion, the egg will quickly complete the second meiotic division and form a mature ovum, so that it can fuse and the chromatids can fuse to form from haploid number to diploid number of cells. This is the diagram which is showing a sperm penetration and cortical reaction. There are actually two reactions. I've just discussed acrosomal reaction, and then there's a zona reaction. Acrosomal reaction and acrosome reaction occurs in the sperm, while zona reactions occurs in the egg. Again, if we have to understand the anatomy, what is actually happening is when the cell is there before evolution, this egg appears as a tubercle on the surface of the ovary. What it is actually, it's a Graafian follicle. There's a layer outside cell, then there is an inner layer of cells as well, which is termed as corona radiata. Then there is a thick outer coat around the oocyte, which is called the zona pellucida, and then there is a cell membrane of the oocyte. So we have to understand that once that Graphian follicle ruptures, these corona radiata cells are surrounding the cells. Sperms come in, and when they come near it, there is three sections of the sperm. There's a head, body, and tail. Head actually contains certain enzyme which is called as hyaluronidases, and these are actually those enzymes which can digest hyaluronidase matrix, which is this is an important point. This hyaluronic acid is actually main part of all this layer which is surrounding around the cell, for example zona pellucida and corona radiata. The release of enzymes causes the lysis of this layer, then lysis of zona pellucida, and as a result helps the sperm to penetrate this layer and reach the plasma membrane. Once it's around the plasma membrane, a further release of different other enzymes results in the lysis of plasma membrane, and actually there is a fusion of plasma membrane of the sperm and egg. As a result, pronucleus is actually dislodged from the sperm into the cytoplasm of the cell. Now this is the diagram. If you see, this is a large cross section of this point. There's the sperms coming in, and this is the acrosome of the head, then this is the body, and there's the tail. These acrosomes, as you can appreciate, they're releasing enzymes. After the rupture, there's an acrosomal bud here which actually releases, it ruptures, and there's a release of enzymes into the outer environment which causes the lysis. So this is the corona radiata layer which is surrounding it, and it is causing the lysis first. Then goes the zona pellucida layer, and then there is a plasma membrane inside, but gradually it's lysing it up and entering and fusing it with the pronucleus of the egg. This is another diagram which is showing another schematic reaction, acrosome reaction. Now if you see this is a sperm which is coming in, this is the acrosomal granules which are present, then there is a nucleus. Now this is the nucleus, then this what we are talking about is the pronucleus, then this forms the mitochondrial material. Why this is mitochondrial material is needed? Because a lot of mitochondria is needed so that it can propel the sperms towards the egg, and for a sperm it's a million mile journey to reach the egg. So this is the body, and then there's the tail. This is the head section which contains the acrosomal granules and a pronucleus. Now if you see, there are two layers over here. Now it's only showing a jelly like coat which is actually the zona pellucida and mainly formed of hyaluronic acid. As inside there is a vitelline layer and protein receptors, and then there is a plasma membrane here. As it's entering in, it ruptures, releases enzymes, as you can appreciate over here, and once enzymes are released, it keeps on penetrating them. Gradually there is a fusion over here when the plasma membrane of the egg as well as the sperm are actually fused, and at this point now this pronucleus is free to be released into this egg cytoplasm, and this results, once this pronucleus is in, this can fuse with the pronucleus of the egg to form a zygote. So this is acrosome reaction. What is the zona reaction is actually going on right here, that once this stage has occurred, that there is a fusion of plasma membrane and one of the pronucleus of the sperm goes in, there are changes in this jelly coat layer which is the zona pellucida in such a way that it becomes impermeable to the other sperms, so that the other sperms just cannot penetrate the zona pellucida despite having acrosomal enzymes to digest it. This change in the layer is actually termed as zona reaction, so that once the one sperm which has already penetrated will only fuse to form zygote, other sperms cannot penetrate the cell. So now we are coming to the cleavage. What actually happens is, now if you see this diagram, now this is the stage of second meiotic division, metaphase. The reason I discuss metaphase again and again, because it will be very easy for you to appreciate that these are the centromeres which are aligning themselves the two poles, and gradually from metaphases they are being dragged to anaphase, and telophase is about form. Now there are two polar bodies is already formed, means the first cleavage which occurs after the telophase divides a single cell which contains diploid number of nucleus into a two cells. Now this two cell will further divide by mitosis to 4 cell, and 4 cell to 8 cell, and 8 cell to 16 cell. Now this rapid division of single cell to 2 and 4 cell stage is termed as cleavage. So what is cleavage? Early division of zygote into multiple cells without increase in size and partition and contents. So what we know is actually there is no increase in size. It's only dividing from 1 to 2, 2 to 4, 2 to 4 to 8, 8 to 16, 16 to 32. By this, once it becomes a 16 cell stage, this is termed as morula, or a ball of, it becomes a ball of a cell which is termed as morula. From here onward, it will further divide from 16 to 32, 32 to 64, 64 to 128, and then into 256. And gradually, at by this time, it will starts to increase. Before this, there was no increase in the size, only it was dividing. By the time it becomes a morula, then it also not only keeps on dividing, it starts to increase in size as well. In the diagram below, you can appreciate this is the stage of evolution at day 14 of the cycle. At this time, it goes into the tube. Fertilization, as I have already told you, discussed that it will occur in the infundibulum of the fallopian tube. As when fertilization occurs, there is acrosomal reaction from the sperms and zona reaction from the egg. Now, this results in a formation. If one pronucleus of the sperm fuses with one pronucleus of the egg, it forms a zygote. This zygote will undergo cleavage but without increase in the size. By the time it's day 2, it has already become reached a 4 cell stage. By day 3, it becomes an early morula, which is an 8 cell stage. By the day 4, it has become the advanced morula, which is a 16 cell stage. From 4, 5, and 6 onward, gradually by 7th to 10th day, this is at stage of implantation. And by the implantation, the first week of this called first week of development becomes completed, which is termed as the period of zygote. Important thing is what is a blastocyst, blastula, and what is blastocystic cavity. Now, as I've already told you that we'll be discussing now, this is the diagram which is showing how this zygote actually converts into blastocyst. So there is first cleavage. What is cleavage? Then it is 2 to 4, 4 to 8, and 8 to 16 cell stage. There is no increase in the size. As you can appreciate right here that there is a zygote, which is a fertilized egg. It becomes 2 cell, then 4 cell stage. Then by day 3 or 4, it becomes a morula. Morula is a 16 cell stage. But now by this time, there is also not only increase in number of cells, there is also increase in the size of the cells. Size, they're constantly dividing and dividing, and as well as increasing in size. So what happens is when the size becomes big enough, there is a certain process called as compaction. Compaction means to come together. So what happens is the cells starts to come together and align in such a way that they are closely and tightly packed together by release of certain proteoglycans, which make them hold together and come more closer to each other. As a result, there is a cavity starts to appear in between this, which is termed as a blastocyst cavity, as you can appreciate here. So this is the cells which are actually clumping together, and this is a huge cavity which starts to appear in between. This is formation of early blastocyst cavity, or at this stage this is termed as blastula, or when the cavity is termed as blastocystic cavity. It can also be termed as blastocyst or blastula, and this cavity is termed as blastocystic cavity. Now when this is the diagram which is showing that actually these cells which have started to divide, they divide into two forms of cells. There is an inner mass of cells and there is outer layer of cells. This is the important concept, that how these cells clump together, because this outer layer is going to give rise to two other layers which I will be discussing in the next lecture, and I will be discussing the formation of bilaminar disc formation. And this inner cell mass is actually embryo proper, which will give rise to the proper embryos, embryonic parts, and all these heart, and eventually all of the body parts of the embryo will be formed from the inner cell mass. On this diagram below, this is again evolution. Oocyte has come into the tube. Here the fertilization has occurred in the infundibulum. And as I told you, this is day 1 at a max, or day 0, because oocytes cannot survive more than 24 hours. So fertilization has to take within 1 day of the ovulation. Once that is done, the cleavage starts, 2 cell stage, 4 cell stage, then eventually 8 and 16. By this fourth day, there is a formation of early morula or advanced morula formation. This continues to divide and increase in size, and then there's a cavity formation which occurs in these cells, which is due to the compaction. They come close together and a cavity starts to appear. This is called as blastula. This cavity is termed as blastocystic cavity. This outer layer will give rise to two cells layer, which is cytotrophoblast and citiotrophoblast, which will help in implantation of the embryo at 7 to 10 days. So, coming to the hormonal changes during pregnancy, this is the ovulation and fertilization. This, if you see, this is this time evolution has occurred. And before, this is actually continuation. I've discussed this in the last lecture, that initially the levels of progesterone and estrogens are low, but before evolution there is an LH surge, and at this point, once evolution has been done, there is a gradual increase in progesterone level, as you can appreciate right here. Why it is increasing? Because corpus luteum, which has been formed in the ovary, is secreting progesterone. There is also a gradual rise in increase in estrogen level, because these Graphian follicle cells secrete estrogen, as well as some amount of estrogen also secreted by corpus luteum. So it has to increase. There's a secretion of human chorionic gonadotropin. Why this is increased? This is not present. The uterus will not prepare it for the implantation. So there has to be increased level of beta hCG, which there's a trigger, it's kind of a signal that for the uterus to prepare for the implantation. Once HCG is raised, by this time, this is the time of ovulation and fertilization, and by this you can see in terms of weeks. At max, the maximum level is reached 8 weeks of pregnancy. By the time it crosses 16, it levels becomes almost normal. So there's an important point as well here, that hCG levels can be measured, and beta hCG levels are actually measured to confirm in blood test for the pregnancy, as well as when the urinary pregnancy test is actually performed. This strip on the urinary pregnancy test detects beta hCG levels in the urine, which are actually secreted. So the high levels of beta hCG levels signify pregnancy. So now we are left with implantation. As it's embedding of a blastocyst into a uterine lining begins at day 7, it takes around about 1 to 2 days, and around its 7 to 10 days implantation has also been completed. We all know what is a blastocyst, which is our blastula, is that stage in which the compaction has occurred. Now cells have aligned them in such a way that there's the inner cell mass, there's the outer cell layer, and there's a blastocystic cavity. So outer cell layer, which I told you, now this, if you see this diagram, this is the inner cell mass, this is the outer cell layer. Now this outer cell layer will actually give rise to another two types of layer called as trophoblast, which is further divided into a cytotrophoblast and syncytiotrophoblast. This outer layer, which has to embed itself into the uterus wall, will form the syncytiotrophoblast, and this trophoblastic layer, which is surrounding the inner cell mass, will form the cytotrophoblast or cellular trophoblast. As you can appreciate right here, now you can see this is syncytial trophoblast or syncytiotrophoblast, which is actually embedding itself into the uterine cavity, while there is a cytotrophoblast, a cellular trophoblast, which is surrounding the inner cell mass. So, a trophoblast is the outer layer of cells. Inner cell mass will form the embryo proper, while trophoblast form the syncytial trophoblast, which erodes into the endometrium. where cellular trophoblast carries the nutrients to the inner cell mass. This inner cell mass has to survive because this is the embryo which is going to be the later on form the fetus and then eventually give rise to a baby. So this nutrients are being actually carried by a cellular trophoblast, while sensitive trophoblast is a main role in implanting this embryo into the uterine wall. Gradually, when they invaginate into this, there's a lacunae appear. Lacunae are actually filled free spaces which appear in the endometrium. There is a lysis of endometrium, and as you know that there is endometrial lining is such that their spiral arteries are extending into the endometrium. There is certain sometimes these spiral arteries walls are eroded in such a way these lacunae then later on become blood filled, and thus the oxygen and nutrients which are coming from the spiral artery into these lacunae are then absorbed by the cytotrophoblast in for the inner cell mass, which is the embryo. So that's how the nutrition and the blood actually goes towards this embryo at 7 to 10 days post plantation. So this is another diagram which is showing an enlarged view of implantation of a blastocyst. As we know, this is a blastocyst, and this is the trophoblastic layer. This is the syncytial trophoblast. This is layer surrounding the inner cell mass is the cytotrophoblast. As this layer has to invaginate into this, so this, as you can appreciate, the sensitive trophoblast is invaginating into it. This is an artery. As it goes in, it only erodes not only the endometrial wall, it sometimes erodes the wall of the arteries, and as a result the spaces starts to appear in between, which is from the lacunae. Sometimes these spaces are very adjacent to the artery, and once the arterial wall is eroded, blood actually flows from this arterial wall into these lacunae, which become blood filled or blood pools. From then the nutrition is goes to the embryo via diffusion from these blood pools into the main embryo proper, which is the inner cell mass. So what I have covered up till now: fertilization, zygote formation, cleavage, morula formation, and implantation. Have you ever wondered, can implantation go wrong? Yes, it can. And if it goes wrong, it's a clinical situation which is termed as ectopic pregnancy. Now, we all know that it has to travel all along from the tube into the anterior posterior wall of the uterus. What if, for some reason, this is disturbed? This movement across the tube is disturbed, and fertilization and implantation, instead of occurring in the uterus, it occurs in the fallopian tubes. Then that is termed as ectopic pregnancy. So we will be discussing the definition, etiology, risk factors, signs and symptoms, diagnosis, and management. What is definition? Any pregnancy where the fertilized ovum gets implanted and develops in a site other than normal uterine cavity is termed as ectopic pregnancy. So the normal site is anterior and posterior wall of the uterus. If it implants anywhere other than this in the uterus, this is also ectopic pregnancy, but intrauterine ectopic. If it implants anywhere outside the uterus, this is termed as extrauterine ectopic pregnancy. This could be tubes, this could be abdomen, this could be ligaments, or anywhere else. So this is the diagram which is actually showing an intrafallopian extrauterine ectopic pregnancy, as the fetus is actually implanted in the tube. Now tube is a very small place, it cannot grow and become a baby in here because this uterus grows as the gestation progresses, but tube cannot go. So this will be a time when this will rupture, and this rupture will be catastrophic and can lead to the death of the mother. So, what are the implantation sites? As I have already told you, it could be intrauterine, that anywhere inside the uterus but not in the normal place, or extrauterine, which includes outside the uterus. Mainly it in the tubal, which is in the tubes. It could be in the ampulla in 70% of the cases. It could be at the isthmus in 12% of the cases, union in fundibulum at 11%, interstitial, coronal at 2% of the cases. It could even implant itself in ovaries or inside abdomen. So this is important. It could be intraperitoneal or extraperitoneal. Usually there is a broad ligament which is holding the ovaries and uterus together. So this may get implanted in broad ligament. Uterine is, if it's not in the anterior and posterior wall of the uterus, it could be in cervical region, in cervical os. It could be in angular, coronal areas, and intramural. This is all termed as intrauterine ectopic pregnancy. Now this is the diagram which is showing, as you can appreciate, it's in the interstitium. This is around the cervical os, intramural is inside the muscle. These all are showing the extrauterine tube ectopic pregnancy. This is the broad ligament which is surrounding the uterus and the abdomen. It can dislodge here. It can even get fertilized and implanted in ovary. Mostly it is gets fertilized in the tube, which could be in the fundibulum, ampulla, or stomach level, or sometimes it can get in the interligamentous area and get itself implanted around the ligament which is surrounding the ovary and the tubes. So what are the causes of this etiology or ectopic pregnancy? This the mainly causes are divided into two. One is the congenital, which are those causes which are present by birth or which is due to certain anatomical defects which are present by birth. One mother is not able to conceive properly. As a result, once it conceives, the fertilization occurs at a abnormal place. For example, it could be due to tubal hypoplasia, tortuosity of fallopian tubes, congenital diverticuli, partial stenosis, elongation of tubes, or intramural polyp. Or it could be acquired causes. Acquired causes are those causes which usually may be directly and indirectly related to our behavior or environmental factors which can cause ectopic pregnancy. Most common is pelvic infections. Infections actually cause initially the inflammation, then there's this fibrosis and scarring, and wherever there's a fibrosis and scarring, there's eventually lead to slow down of the movement of this egg and fertilized zygote through the tube, and this can result. Zygote has to implant in 7 to 10 days. If it takes more than 2 weeks to get out of the tube, then this would result in itself implanting around at 7 to 10 days in the tube and will result in ectopic pregnancy. Other is contraceptive failure. Contraception is usually, as this diagram is showing, that intrauterine contraceptive device can be placed to stop fertilization to occur. But at times, what happens is that it cannot stop fertilization still does occur and contraceptive failure does occur, but what happens is it's still able to slow down the movement of egg from the fallopian tube into the uterus. As a result, although it has failed to stop fertilization, but this fertilization which has now occurred will result in implantation at a false site, for example healing the tube. So, what other causes? Then there are certain other acquired causes which could be due to surgery. That if there is any kind of a surgery, usually surgery leaves a certain amount of scarring of the tissue, and scarring the tubes can lead to slow progress of this zygote through the tube, which may lead to ectopic pregnancy. For example, what are these procedures which can lead to ectopic pregnancy? Include bipolar cauterization, unipolar cautery, silicone rubber banding, interval salpingectomy, postpartum salpingectomy. And then if there is instead first there were these are some of the contraceptive methods as well that you was done. And then if any of the couple who want reversal of this reversal will have to form and they have to undergo another surgery, and this will go for further scarring. For example, what are the reversal of sterilization procedures include? Depends on the method of sterilization, site, and tubal occlusion, residual tube length. Reanastomosis of the cauterized tubes and reversal of permarize as a procedure. What in this permarize procedure, what they do is they cut the ends of the tube, they tie it backward so that these tubes can the ends cannot fuse with each other. As a result, if there is a egg which has formed, goes into the tube and gradually after 24 hours gets degenerated there without going into the uterus. But if this Now, this surgery would cause some scarring. If you have to reverse it, that would cause further scarring. So, once the reanastomosis is although adequate and still egg can come, but this movement of egg would be too slow to go to the uterus and can lead to ectopic pregnancy. So, what are the risk factors? These are tubal reconstructive surgery or assisted reproductive techniques, or there is if there is already a previous ectopic pregnancy, there is a very high chance of having a ectopic pregnancy this time. This is the diagram which is showing an fetus in the infundibulum of the tube, and this is the uterus. This is real-time diagram of an ectopic pregnancy. How would that ectopic pregnancy present? Now, it can present either as ectopic pregnancy only or ruptured ectopic pregnancy. Ruptured ectopic pregnancy is catastrophic events. Once rupture occurs, it could be very damaging for the patient and it's life threatening. But some of the sign symptoms would include pain, amenorrhea, and vaginal bleeding. These are the triad of sign symptoms. Other include feeling of nausea, vomiting, fainting attack, syncope due to reflex vasomotor disturbances. But mainly it is the pain and amenorrhea and scanty vaginal bleeding. Coming to the investigation, we have to go through simple baseline levels and blood CP. There will be low HP. Why? Due to loss of blood. Caldocosynthesis will reveal blood. Now there is a cul-de-sac which is lying anterior to the rectum and posterior to the posterior vaginal fornix. If you insert needle into it, there will be an aspirate. There will be blood present in the cul-de-sac. Now this is termed as cholestasis. And why this is done, this was nowadays not done, but it used to be a pathogenomic test for having a bleed in the cul-de-sac. Beta hcg level, beta hcg level denote pregnancy, so they would be definitely high. Our serum progesterone level, as corpus luteum is present now and it's continuously secreting progesterone, so they will have high progesterone level as well. Nowadays, shift is more towards the non-invasive test first and then going to the invasive things like cholestasis. And this includes abdominal ultrasonography. Nowadays, a new modality has come into the practice which is called as transvaginal ultrasound. This is most important in delineating the anatomy and diagnosing ectopic pregnancy. So, if there is a suspected case of ectopic pregnancy, we have to decide whether this is ruptured or not ruptured, or is about to rupture. How will we decide? We'll perform the ultrasound, mainly the transvaginal ultrasound. And first of all, it has to be, if it's intrauterine sac, it's not an ectopic pregnancy. Sac should be in the uterus. But if it's not in the intrauterine sac, then we have to see the quantitative serum beta hcg and progesterone levels. If they're less than 66% rise, then go for DNC. If there is more than 66% rise, repeat serum HCG level 40 hours till ultrasound discrimination zone occurs. Why if there is high? So there may be a normal pregnancy, but it yet has not reached the implantation site. So we may have to wait here. But if we know that this is less than rise and still it's outside, just go for DNC. And if villi are present, this is termed as incomplete abortion, or if villi are absent, go for laparoscopic removal of the ectopic pregnancy. So the management starts from the history. We have already taken the history. We know there is a pain, there is scanty bleeding, there is amenorrhea. On examination, there may be a lower abdominal tenderness. Once we know, we'll be going through the blood test. The HB would be low. On transvaginal ultrasound, you may pick up a tubal pregnancy. So what is the management? Then medical management includes, if it is not ruptured, it could be divided into two: systemic or local. Systemic is giving the mother methotrexate. This will result in the death of the zygote or the embryo which has been formed, and this will go in. Other local includes local ultrasound guided or laparoscopic guided salpingiotin synthesis, which uses methotrexate, potassium chloride, prostaglandin analogs, hyperosmolar glucose, actinomycin D, and mifepristone. While surgical managed, if it has ruptured, then you have to go for either laparoscopic or open laparotomy has to be performed. But radical salpingectomy is not a good option only in those who have mothers who have yet to complete their family. But in those whose family has been complete, we can take out the tube easily. In case of conservative management, it would include salpingostomy, just making a hole in the tube, salpingotomy, or segmental resection, or milking of fimbrial expression. So if it has ruptured, it's devastating and catastrophic event, and it can be life threatening. So the options are resuscitation and laparotomy. Nowadays, focus is shifted from resuscitation laparotomy to first resuscitation, then laparoscopically taking it the ectopic pregnancy out. So coming to the summary, we have discussed that there is a fusion of spermatocyte and oocyte to form a zygote. Zygotes divide under 2 and 3/4 cell stage. At 16 cell stage, it becomes a morula. For morula, it keeps on dividing and increasing in size to form a blastula. Then there is a cavity which appears. Later on, cavity appears in a solid ball of cells forming a blastocyst. Blastocyst lodges an intrauterine cavity at 7 to 10 days post fertilization. If embryo implants anywhere other than the uterus, it is called as ectopic pregnancy. So we have covered almost all the topics in this lecture. Thank you very much and keep watching sqadia.com.